This is the second video in the basic data manipulation with R module, and so if you haven't watched the first one, you should probably do that because we're going to go a little bit quicker in this video. But to review our objectives for the module, we're doing basic data manipulation using standard R data frames, and in particular we talked about viewing and summarizing the data frame, element selection, individual element, column selection, and we looked at column selection where we created new data frames and where we extracted values. Row selection, where we select individual rows into a new data frame, and then logical indexing or masking, where we are filtering the data based on a logical condition. So we're going to continue that in this module. We pick back up in our sample data frame script. You can see this is where we left off with empty cars. And for this module, we're going to read a data file. So rather than using one of the built-in data sets, we're going to read a data file. And to make sure this is working correctly, one thing that's useful is to look at your current working directory. So just print and then using the function get working directory shows you exactly where what your current base directory is. And that's important for setting this path information for the data file. So the data file that we're going to read is our economic indicator data that we have here. And my interpretation of my path says that I start at this directory, and then I back up one level, and then I back up another level. So I'm back 2 levels down to this INSY 6500. I move forward in data, and that's the location of the data file. So in order to read the data file, this is a standard comma-separated value file. And so I'm just going to use the read CSV. The only setting I have is I want strings as factors set to false. So when it reads string values, it reads those in as strings and doesn't read them in as factors. So I execute the command. Let's see here. Let me get to my line here. Execute the command, and we read the file, and we can look down here, and it appears to have been successful. If I just use the head command and look at the first 10 values, you can see this is the data set that we used a couple of video modules and homeworks back, where we have by month the unemployment rate and the jobs added, and then by quarter we have the GDP values. And so we'll use our standard method to have a look at the data. The first thing I'm going to do is do str, which gives me the structure. The structure tells me I have 128 observations of 4 variables. I have a month variable that's character, unemployment, jobs added, and GDP are all numerical values. Also note that over here in the global environment, I can also look at the data in the familiar spreadsheet view. And so this is essentially the same thing that we did in the previous video, except we were using built-in data sets rather than reading the data from a file. We can also look at the summary. We want to get a summary of the data, and you can see that what the summary does is gives me some descriptive statistics, or summary statistics, of the numerical values in terms of unemployment rate, jobs added, and GDP. Okay, so we have our data set read. The first thing we're going to do is we're going to look at a couple of basic plots. And so we're just going to use the most basic plot functions because we haven't really talked about graphics yet. The most basic plot function, I just give it the values that I'd like to plot. And so recall when I run data unemployment rate, if I just do this right here in the console and do data unemployment rate and execute that, then it returns a vector, right? So it reaches in that column from the data frame and returns a vector of values. And then what happens is I just feed that to the plot, and I'm using a type L plot, which is basically a line plot. And so now you can see my line plot of the unemployment rate. We can do the same thing with jobs added. Execute that, and you can see the jobs added. Again, the same thing. I use the data $ jobs added to extract the jobs added values from the column into a numeric vector. The difference here is that I use the O type, and so now we can see the individual points and then the connector between the lines. So finally, let's try this on our GDP data. So we execute using the same logic, and it looks interesting because we have the dots, but we don't have the connector, so we don't have the lines in between the dots. So we can look over and say, well, let's just try making a line plot. So we do that, and we just execute that again, and now we don't have anything. And so since we've already worked with this data, hopefully we suspect what the problem is, or if you've read the next line in my code, we have some missing data. And if you look back at our data set, as we know, or as I said in the beginning, the GDP is reported on a quarterly basis. And so 2 months out of every quarter, I don't have a GDP value. And so that's exactly what we're seeing here, is that the plot doesn't know how to connect these when I do the type O plot. And if I do a type L plot, it doesn't do that. It doesn't know how to plot that. So we basically have a couple of choices here. The first thing that we can do is we can just filter the data. In other words, in this case, we're going to get the quarterly data. And so what I'm going to do is I'm going to use a sequence. And so let's take a look at what this sequence does. It's a sequence from 1 to the number of rows. There are 128 rows. We can see that right here. And then it does it in step size of 3. So we look back at our data and we're going to have the first one, then we're going to step 3 and get the second one, then we're going to step 3 and get the third one, and so on. And we can see that if we just grab this guy, copy it, and then just paste it straight into the console, and you can see that step size. So this is month 1, month 4, month 7, month 10, so on, the quarterly values. And so when we execute this, we now have a quarterly data frame that's got the same columns, and we now have quarterly data. And so now when I plot using the quarterly data, you can see that I have the same dots, but now I have they're actually connected. So again, if you compare that to this plot, it's the same data points, but they're actually connected when I do this plot because we don't have any missing data. We've extracted that missing data by doing this every third month step. So now that we have that, let's try extracting some useful information. For instance, let's try to get all of the months with more than 300,000 jobs created. So the jobs numbers are in thousands, and so what I'd like to do is extract those values. And so what I need to do is have a mask condition, and my condition is that the jobs added are greater than 300. And so if I just execute this, if I just look at that command, look at that expression, do it here in the console, you can see that what I'm generating is a Boolean mask, and so I have a true-false value associated with each one of the rows as to whether this particular condition is true. And then we can apply that. Let me create the mask here rather than do that. Yeah, create that. Then we can apply the mask to our data, which has all of the data. Note again that I have this trailing comma, and something that I often forget, so I keep reminding you. Hopefully you won't. And now we have a new data set called Big Jobs Added. So Big Jobs Added includes those months where the number of jobs added is greater than 300,000. And you can see we successfully filtered the data into that data set. So now suppose we want to do something similar with months with greater than 18,000 GDP. So we're going to do the same thing. We're going to create a mask using the new condition. And now we're going to mask, or we're going to filter into big GDP. As I mentioned here, we should look at the data set. So we look at big GDP, and the very first thing we see is all of these NA values. So what happens in the filtering condition is it doesn't know how to deal with the NA. It doesn't know how to filter that out. In fact, we didn't tell it to filter that out, so it just adds those in. So the first thing we want to do, or the next thing we want to do anyway, is we want to omit those NA data. And so what we're going to do is we're going to use the omit command. And so if you look at that, there's the help, and it's part of a group of functions that help you deal with bad data. And so what we're going to do is we're going to call the NA omit on our data frame and specify which column we're interested in checking for omit, or checking for NA values. And so when I hit Control Enter, then I created a good data set. And so this ends up being the data set, or the rows from our original data set where the GDP value is not NA. So we have an actual, the actual GDP values. And so when I go back, I can then create my big GDP data set. And so my big GDP data set, again, filters from the good data, the ones that have the particular condition. The condition here is that the GDP is greater than 18,000. Okay, so finally, the last thing I want to do in this short video is talk about the difference between these two methods. So what we did, let's see if I can find it, right here, we basically extracted the same data set. Right? So if I look at quarterly and then I look at good, they're essentially going to be the exact same data set because they both, the purpose was to extract or get rid of the NA values, but we did it in two different ways. The quarterly data set, I assumed that I had quarterly data, and then so it just went in and pulled out every third row. Right? It pulled out every third row and created a new data set with those. The NA omit, when we created the good data set, is it went through and extracted or deleted everything, all of the rows that had NA values. And so practically speaking, in this case, we ended up with two identical data sets. But in general, the NA omit will omit any rows that are NA. So if we had missed some quarterly GDP values, then the NA omit would have omitted those and the results would still have been presented. Whereas if we had some missing data on the quarterly GDP, this method would not have solved that problem. And so the question of which one you want to use really depends on what you're after. If you want to detect cases where you have missing data, so maybe I want to know that I missed a GDP data, then this assumption of pulling out ones where I expect to have values would be the correct approach. If, on the other hand, I just want to calculate or plot or do some I want to do some task on all of the data that's not missing, then this one would be the approach. And so in this case, we ended up with the same data set. In this case, in general, we could end up with different data sets, and the one that's the right way to use really depends on what you're trying to achieve. So again, back to our objectives. Again, we looked at viewing and summarizing our GDP data and our jobs added and so on. We didn't do any element selection in this one. We did that in the previous one. We did some column selection when we wanted to do some calculations. Row selection, we did two maskings, and then the logical indexing we did to try to find good periods of time in terms of either job growth or GDP.